Hey dudes, today we're going to learn about Agile project management, how to lead tech teams, and then we're going to do our tech time again because tech time seemed like you guys like it and you learn a lot. Cool. So as I was talking about last time about the product development lifecycle and the different ways that we can do things, there are two main types of product development. One is the waterfall method, and the second is Agile, which is the one that we're going to be using. But first, I'll describe the waterfall method. So the waterfall method has been around for a ton of time. The way it works is that there are designers who initially go out, find what people need, along with the product managers. They'll come up with every single feature and every single idea before everything, and they'll create a huge user requirement document. And in that user requirement document, they're going to talk about everything from the tech stack to the design to all of the dependencies that are going to be inside of there. It's really just a huge project. And what they'll do is they'll have this huge document with all the different features, all the different requirements, and say, okay, well, we're going to do this over an 8-month time period. And it's really, really good in terms of visibility to the CEO, to the analysts, to everyone who's involved, because they understand what's going to go down all at once. They can see everything, a huge scope, and it's what businesses have been doing for a super, super long time. However, it has a lot of drawbacks. Because every single step depends on the step before it, it reduces the amount of speed, it reduces the amount of iterability. Say something changes, say you get new information from your users that, hey, they actually don't like this one thing, then it's going to be really, really hard to go back and change something because you have this entire list of features and this entire document built off of something else. So that's where Agile product development comes into play. Now, Agile is a newer method of product development. It was pioneered in Japan by the people at Honda and Toyota. And the way they found out about this is they actually looked at, out of all things, rugby teams. They saw how rugby teams collaborated in between every single play or whatever, how they would communicate about what they were doing, what wasn't working and what was working, and then how they would then go out and execute on that. And they found that teams that worked on features in chunks rather than doing everything all at the same time actually went a lot faster, and the quality of their product was a lot better. And that's because in every single sprint, you can focus on one specific thing and everything about that. You can define the requirements, and once you develop that one product or that one feature, you can send it out there, get feedback on it, and then iterate upon that and really kind of perfect that. So instead of creating all the features at once, what Agile allows you to do is focus on one feature at a time, and then when changes occur or when changes happen, you can then address those and create features as you go, more or less. So why Agile? As I said, you get faster iterations. Think of it as instead of creating a monolith, right, which is just one huge code base or one huge project, you're splitting that up into pieces, and you have a product backlog or a feature backlog, which is all of your ideas and all of your solutions to all these different problems, and you're constantly refining that and switching around the priority and talking with your team or the stakeholders and seeing what's most important. Then at the beginning of the week, you'll look at that and you'll say, hey, this is what we're going to focus on for this allotted amount of time. You're going to break that up into tasks of all the different things that you need to do, and you're going to assign it to people. And that's really the best way to do it. It's what every single modern tech team uses, and we're going to get you guys familiar with it right now so that when you go out into the workforce or when you go work at a startup or when you go start your own project, you know the best way to organize and work on projects. Cool. So yeah, Agile is really focused more on creating stuff that works rather than documenting it. That doesn't mean you shouldn't document what you're creating and kind of create a structure to that, but it's really important that it's more of action rather than concept, right? It's more doing. And yeah, you're able to respond to change a lot better. So as I was talking about earlier, there are like several different parts of the Agile process. There's the product backlog, and the product backlog, like I already told you guys what the product backlog is. You put all of your ideas on it, and then at the beginning of the week, there's like a sprint meeting. And at the sprint meeting, you get everyone together, you say, okay, what have you done last week? Have you done all the tasks that were assigned? If not, you move it over to the current sprint, to the to-do list. But then you'll like focus and say, okay, like here are the things we want to get done today. Here are the features that we want to create, and you're going to break that down. And this daily Scrum meeting, Scrum is a term that's taken from rugby, and like I said, it's really just it's a description of a team that talks almost constantly and communicates really well what they're doing and is able to change and iterate really quickly. This is based off of like people who work every single day, because when you're at your job, you're working every single day on the same thing. So they're like daily Scrum meetings, but obviously like that's not reasonable. Like you guys probably aren't going to be working on this every single day. What I think would be good though, and you can decide this with your teams, are like weekly, like middle of the week check-ins, so you can understand like what everyone's doing and making sure that like all the work isn't just being put off until right before Sunday. So then like when you present to everyone, you can actually say you've done stuff. I feel like it's going to be really important to like have those Scrum meetings where you can discuss everything. And then lastly, like the last step is the sprint retrospective. You look over on everything that you've done for that week or whatever time period you allotted for the sprint, and you see what you've done, what's good, you test it. People can like give presentations about like what they've done and everything. Usually what you'll see in the workplace, so like every single week in my workplace on Friday, we'll all stand up in front of the TV with this like huge Jira board of all the tasks that were allotted for that one week. And every single person will go through, say what they've done, and they'll actually give like presentations or little demos of like what they've done. So like the designers will be like, hey, I created this new user experience, so here it is, here's a prototype of interaction with it. Same with engineers and everyone else. There's always a demo, but obviously it's like up to you guys to decide what that looks like. And I'm thinking that it could happen on Sundays when we're having the general meeting. We're going to give you guys a lot of time to plan for the next week and to have these sprint meetings that are super important. So yeah, cool. A key part of this is a key part of product management, and kind of this subset of project management, which is like execution, is keeping everyone on the same page and understanding timelines and planning things out. When you're creating sprints and you're assigning tasks for that sprint, you're helping everyone on the team understand what needs to get done and what is expected to get done over a certain time period. And road mapping can be thought of as an even bigger picture. It's like the big picture of the entire product. So road mapping can have a lot of different names. A really common name is an epic. You know, an epic is like this big, great, gargantuan thing, and it's actually the name that we're using in the Notion template that I created. But it's pretty simple. Roadmaps or epics are these really big chunks, these like really big overarching goals that are used to, you know, really organize what everyone's working on. So for example, something on here would be like a completely new feature, say like the login feature. That would be an epic, right? That would be put on the roadmap. And within that, like if you break it down one step, you need to break that into tasks, right? Because you can't just put on the board to do create login sign up feature. There's a lot of stuff that goes into that. There is, you know, like the user experience. There's the design. Like, do you want to have a forgotten password feature? Like that has even more tasks behind it. Do you want to have like text message verification, like the two-factor authentication? If there's like a front-end development, there is a back-end component of that. And for back-end, if you're doing login and sign up, there's probably going to be authorization as well, right? Like how do you authorize whether a user is actually allowed to access a resource? How are you going to store that? Is it going to be in cookies? Is it going to be like stored? Is it going to be stored on the device? Like all these different things. Epic, big picture, task, smaller picture that make up the epic, and with those tasks you assign it to everyone. And I'm going to go to the Notion template to show you. Yeah. Sprints are just time periods. That's it. All right, now let's go ahead and go into Notion. And I will show you guys how to create a roadmap, how to organize sprints, and how to use this template that I've sort of created. Cool. So as you can see, I'm in the SG Connect page, and let's go ahead and focus on the roadmaps and tasks. And let's start on epics. So as I said, epics are the large overarching initiatives. They're like really big picture kind of things. And these are going to be like the big features. So every single week, you're going to come back to your epic list and you're going to see, hey, like, what have we done? Like, what features are most important to be done this week, right? And like, ideally, you're going to have a huge list of these, right? You're going to have a whole bunch of different ideas of a whole bunch of different solutions. And hopefully by the end of this week, you'll have like all the features that you want to implement for the semester, and then you can kind of organize those. But for example, say there's like a forgot password feature. We're at our sprint meeting on Sunday. We've already discussed what we've done for this week, and now it's time to move into what we're going to do for this semester. So here are the epics, the overarching goals, and you can create a new one pretty simply. You can either click new down here or new up here. So I'll just go ahead and click new here and open this as a page. Here you can I created a whole bunch of different templates that you could fill out for tasks, bugs, or project specifications. And we can look into those, but really all you need to do for an epic, because it's like such a broad and big idea, is you can just write it down. So let's say, I don't know, anyone have a feature idea? Let's say, no, feature idea? Sure, login page. That would be something that would be like an epic, and then for that week, you would then create like a timeline of, like what time do you want to do this feature. And maybe in the future, you'll have multiple features that are going on at the same time, split up between engineers. And what you could do is you put the start date, which right now is like the 27th, and then you could go and put the end date. So let's say it's like a week long. And I could assign that, I could open it up, assign this to Derek, and whoever else is on the team, and you could come up with another one. Like instead of a login page, it could be a sign up page. That would probably be over the same timeline, and you would assign it to Yash, right? And then through all of that, you could actually see that stuff right here on the calendar. So everyone is kind of organized and can see that. And then also during your sprint meetings, you're going to go into this part. And as you can see, there's the forgot password feature here. And then you're going to start just rattling out tasks, really. You're going to start talking with everyone and breaking it down. Hey, what needs to be done for the forgot password feature? There's always a design part. There's always understanding the user flow and the user experience, which is probably going to be what you guys are going to work on. Designers and product managers work really hand in hand to understand the users really well and to understand how they use the product. And they kind of define what that's going to look like for the engineers. And the engineers are just really incredible at executing and creating something tangible that actually works. So what you'll do is you'll say task. For example, I just created the plus button, and then I would go in here, create information hierarchy. Or information hierarchy. Dude, I don't know how to spell hierarchy. Hierarchy. There you go. Hierarchy. Hierarchy. Okay. So create information hierarchy and wireframes on Figma. You would assign it to your designer, and maybe you two. Maybe you want to do user interviews, because this is a really big feature that's kind of confusing. For a login or sign up page, probably not so much, right? And you can associate it with which epic it is, right? So you can associate it with that epic, so everyone knows what it's a part of. And you can ignore the sprint thing, honestly, because sprints are just supposed to help you understand like what time period it should be worked on. You could really just put that in timeline and then make sure to create an end date so everyone knows when that is. It'll show up on the calendar. Assign that. So let's just assign it to me. And this will be the task. This is, yeah. Spend a lot of time on a template, so please use it. It's fine. You don't have to answer all this stuff, but it's just kind of there to help you, to guide you along the process. And yeah, that's pretty much it. Just create tasks for everything. I could go on and create more tasks for the example, but I'm sure you guys are competent enough to understand how to actually do that, right? And don't just like be like, oh, like you have to do this, you have to do this. Like obviously work with your team, like get feedback, make sure that they are doing tasks that they think are good. But at the end of the day, like it is your job to like influence and make sure that everything's happening on track, right? Cool. Also, by the end of this week, hopefully you have like the feature list and kind of like write down all those features like on like for like the entire rest of the semester, and hopefully like understand like try to map out like realistically with your engineers and designers what can be done every single week, right? There are going to be certain features that take a lot of time. Sometimes you're going to overshoot, sometimes you're going to undershoot, but we want to make sure that we have that timeline built out so we're not like building a whole bunch of like extraneous features and we don't have like at least like one MVP that people could use. Cool? Awesome. Yeah.
So the task that you just made is a part of the forgot. Whoa, never mind.
Oh shoot! Yeah. I totally forgot about some other stuff. So, shoot, where did I put it? Yo, where did I put the task? Oh, here it is. Yeah. That's right here. Yeah. Also, you can change it so you can like. So you're probably gonna label that as a task, assign it to someone. Sometimes it can be annoying to have like the previews inside, so you can always just change that. Right? So then it's like much more compact and succinct. And make sure you put priority on there so people know like what to work on. It's just like also easier to do it this way. So priority, yeah, and then the timeline. Priority, timeline, assignee, and then like whether it's a task or a bug or whatever else.
Yeah, I think where I was confused on this view, it also has like blocks that are listed as epics.
Yes. Okay.
I don't see why in this view you would have epics and task
Yeah,
bar.
that's true.
Yeah.
So let's get rid of that.
Okay.
Cool. So I think for every single time that you break down an epic, you should probably like break it down all the way, and like put all the tasks in the backlog, and then prioritize and put to do. To do should only be like what you're doing for the certain week, right? And then backlog is like everything else that has to do with that epic. Cool. And this is like totally variable as well, so you can change it, modify it to whatever fits you guys and your needs the best. Cool. And let's walk through like the rest of the board. So it's pretty self-explanatory. Backlog, as I said, once you break down an epic, all the stuff goes there. That's everything for that feature. To do is what your team is currently doing for the week. In progress, pretty simple. Whenever your team is working on something, and this is going to make a lot more sense once we actually start building stuff, right? Because like right now, like this 1 week, we're making sure that everything's in order in terms of like features and ideas and understanding and all of that. But once you're actually like writing code or like writing a certain part of a feature, designing a certain part of a feature, you're going to put that, you want your team members to put that in progress just so it like keeps everyone up to date. After it's done with in progress, you can put it under review, and it'll be up to you guys to assign who to review, like which work. If it's an engineer, probably assign it to the other engineers or assign it to like everyone so they can see like that it works properly. But just kind of use your own judgment of that. And then blocked is something, it's like a really important concept. when a task is in progress, everyone assumes that the only thing that needs to be done is for you or the assignees to work on it and get it done. If something is blocked, then that means that it relies on someone else's tasks that haven't been completed yet, or it relies on outside information that you don't currently have. It's really important that when something's under block, that you do everything in your power to help your other team members to like get it off of block. And then once everything is done, stick it in dev. And at the sprint meeting or the weekly mid of the week meetings, you discuss everything that you've done, show a demo, and yeah, that's pretty much it. Does anyone have any questions? Cool. And yeah, just like play around with the platform, and it'll be like really useful once you start getting a whole bunch of tasks. This is what I need from you guys this week. It's the product specifications. We're really just fleshing out the entire idea to make sure you guys understand it all. I'm not going to explain all of this, but it's really self-explanatory, like the summary, the pain points, which will then correspond to like features and stuff. User personas. You guys know what user personas are?
Yeah.
Okay.
We're basically trying to get like an idea of like what the person we're talking about, like know our market.
Yeah, so user personas is just breaking up all the different people that are going to use your product. So, for example, Allbirds, right? There are a lot of different people who use Allbirds. There are finance hardos, there are tech bros, and those are two completely different user personas. Maybe there's your grandma who just really loves comfortable, breathable shoes, right? Probably not, but it probably is, some sort of like user segment or user persona. But really, like the user personas are to help you understand your customers better. So we can go inside, and as you can see, you can write down like their age range, location, like where they probably live, education, and then I encourage you to like write a lot of different stuff and talk with your designers about this, because we've already like really gone over we've really gone over user personas and understanding them, and yeah, like you want to know everything about them, but especially like their pain points and what really drives them and why they would use your product. So that's going to be really useful to go back to, because you're always going to be focusing on the user no matter what project you're doing. And then user stories, you're basically envisioning how your specific user persona would use your product, and it's going to like differ all the time, right? So for example, for the user story for a tech bro, it'd be like, well, a tech bro is going to wake up in the cold San Francisco air and like, I don't know, put on some fuzzy socks before he puts on his Allbirds to go walk down Market Street. And then for a tech bro, or for a banker, I'd be like, oh, well, a banker's going to get out of his like cramped, 1-bedroom apartment that he's paying $3K a month for with his 5 roommates, put on his Patagonia vest, put on light socks and his Allbirds, and then walk onto Wall Street into work, where he'll stay there until 2 a.m. You really want to delve into the details so you can understand their pain points and how that might help them. And so then you could write something in the user story. You could write something in the user story like, for the user story, like, comfort's really, really big for the finance hardo, because for every other aspect of his life, his or her life, it's really uncomfortable, right? And you really just like want to talk about that different stuff. And then once you have all of that, go down to implementation and start writing down the different features. Really like break down everything that you think you want to build, and like individual features are, what was it, login, sign up, a profile page maybe, like I don't know, let me get an example. Say like the entrepreneurship platform, right? Where we're connecting student startups with technical talent. Profile pages for the students, profile pages for the startups, maybe a messaging system, right? And then like break it down from there. So those are going to be like the big overarching features that I want you to write down and kind of document. And you can relate it to like user stories that tie into those features. And please have this by Sunday. So then next week we can actually start working on the most important features. Cool? And then I kind of already talked about deliverables. I know it's annoying. I know like filling out all this stuff is not fun, but I promise you it really, really helps, especially when you're in the thick of things and you're dealing with all this shit. Cool? Any questions about Notion, Agile, project management? Really, all Agile is it's making sure that everyone's on the same page and that you're not doing any work that of major change in the market or a major change in the environment or like a major change with the user like wouldn't destroy your project completely. Really focused on speed, quality, and iteration. Derek. Mm-hmm. If you have a major bug, then fix it. Fix the bug. Yeah. Fix the bug, dude. Cool. Do you guys understand if there's a problem, like a bug, like a major bug, that you should probably fix it before doing something else?
I think they're testing like how that policy work for like everyone on the team, like how transparent are we going to be with that? Are we going to be like, hey,
okay.
One before be like,
what's up? Yeah, no, for sure. So, funny story. Let's say hypothetically there is a person who's working at a startup in San Francisco, say this last summer, and this person before the daily sprint, before the daily Scrum meeting, had to have a feature done, but that person was busy hanging out with friends the night before and maybe didn't do that. So this person shows up at the office at like 7 a.m. to try to like grind out this thing that is going to take way longer than like the meeting to do, and in a panic accidentally deletes the entire database for the entire product. But this is hypothetical. Like, you know, like it could have happened, it couldn't have happened. I don't know. We did not just. I mean, the people probably did not just go on and continue making the next project. Like literally everyone that day was working on fixing that mistake. So yeah. In terms of that, you can like split it up. It's up to the PMs really. I mean, like the PMs, it's like it's a collaborative role between engineers and designers, but really like they're going to be the ones who are like, if the bug's super critical and massive, then yeah, like everyone's really going to go on that. You're going to move the other like feature tasks to backlog and put to do like bug fixing. But yeah, that's should be pretty straightforward. I'm not saying that it happened. Totally happened. We really will. We will really never know.
we shall see.
Cool. And then now, it's pretty self-explanatory, but I'm going to talk about the important things to do with every single stakeholder. So like the engineers, the designers, and then like business stakeholders, like the people you're working for. Cool. So when you're talking with the engineers and you're like deciding what you're going to do for that sprint, you really want to make sure that you give them as many details as possible. Engineers can get really, really frustrated when you don't give them enough details. You're just like, oh, like go build the login page. Like maybe some are like really, really good at that, or especially when it's like bigger features, like I don't know, building like the matching system, right? Or like how students will reach out to like startups, or how startups will reach out to students. That's something that you need to define a lot beforehand. You need to define the user flow. You need to define like what happens when, you know, oh shit, when a certain screen comes up, etc. And this is really, really big around error states, edge cases, and transitions. So do you guys know what error states and edge cases are? Okay, cool. So edge cases are parts of a program that usually aren't used. They're like edge cases, right? So there are a lot of different ways to use a product. Most people, most like tech savvy people, use products in one specific way. So, for example, like you're scrolling through Twitter. Like most people just scroll through the feed, hit favorites, like hit retweets, you know, it's really, really simple. But an edge case would be, I don't know, someone who like doesn't scroll through the feed and only goes on search and uses search to find every single post that they want to look at, right? Why would they do that? I don't know. People do really crazy shit. And edge cases usually cause the majority of bugs. and it's honestly like really hard to find it when you're an engineer or you're the person designing the user flow, because you have envisioned one specific way that people use the product, and every single time that you go through it, you're just going to do that one specific way. But edge cases are like, when you're going like, for example, I don't know, maybe you're like scrolling down on Twitter, but like edge case, like people will like scroll up, and maybe like scrolling up like messes something up or something like that. I don't know. Maybe that wasn't the best explanation, but it's really just like things that don't usually happen, but sometimes happen.
So in those cases, should we like, how would we like try to solve a problem like that, or like find out
Yeah.
ways to address like different modes of using your like,
Yeah. Okay. So I have a good example for an edge case. So most people, when they use Uber, they're gonna click onto the Uber app, they're gonna call the car, and then once they get dropped off, the Uber driver is going to say, "Hey, the ride's over." An edge case would be a rider who is malicious and who wants to scam Uber. So they call the Uber, they hop into the Uber, they're driving somewhere, and then that rider clicks cancel, says, "Oh, hey, like I wasn't picked up," in the hopes that they get that ride for free. That would be an edge case. Like that would completely break the entire system, right? You have to account for those types of things, and you have to think of that like with prior knowledge. So, for example, student government, we're going to try to create a product where people can like voice their concerns like anonymously, right? And an edge case for that, like most people are just going to say, "Hey, like I don't like this. This is bad," and then it's just going to post up there. But an edge case could be, "Oh, someone just wants to spam the fuck out of student government because they hate them so much, so they're going to type in like a billion different things." How do you stop that? Cool. Yeah. Yeah, it's just really important to define a lot of these things beforehand, especially in terms of the user flow. In terms of like how that actually goes about, in terms of the logic, in terms of like what's actually going to be run on the server to get these things done, like don't tell them how to code. They know how to code so much better than you. So just like give them a general idea of the user flow and let them handle all of that hard work. Like because you're just not going to be able to do that, right? It's their specialty, it's their expertise. Yeah, and just make sure like when you're assigning features, get feedback on like how long they think it's going to take, or just like at least get a general idea, because you don't want to say like, "Hey, someone build me like the Uber driving system in a weekend." Like that's not going to happen, right? Maybe like a login page, yeah, it could happen, but make sure you get their feedback and you don't just like randomly assign them over like a time period that isn't feasible. And one thing that you need to do is you really need to sell home the idea that you understand users the best, and you should understand users the best, because you're not spending your time coding and you're not spending your time designing. So really spend your time understanding what features need to be made, so then you can convey that very well.
Can you touch on what the empathy maps are, or if that's even relevant?
Yeah. So empathy maps really go back to like user stories and user personas. They're just used to like map out how people will feel when they walk through a certain flow or go through a certain problem or pain point. We can touch on it later, but really like you should cover that stuff under your user stories. Cool. So yeah, these are really self-explanatory things. They're also kind of common sense, but it's really important to understand that developers are their own experts. And really, like when you go into the workforce and you go and work at a tech startup, most of the time, they're going to be paid the most. They're going to be like the most valuable or the most desirable asset, or that's what it's currently like in this market. So you need to be prepared to answer any question they could possibly have and really sell them on why the feature is happening. Like they're not dumb, right? Just because you're the product manager doesn't mean they're going to listen to you. You need to actually know what's going on, and you need to actually be like, "Oh, well, we need this feature because of this, because of these user interviews. These are what they said. These are their pain points." Be a good listener, like understand their problems, understand like what they're going through, do your best to understand like how hard coding is and how sometimes things just don't work out how they happen. But yeah, and then like really, like I said, drive home that clear vision and try to inspire them to like work on the future and really emphasize the importance of it all. And yeah, lastly, like work closely. It's in this new age of like remote working. Have you guys ever heard like of remote working? It's a really like big new trend, especially in tech. So people from all over the world will work together on a project. But there actually is something very, very valuable about all working in the same room or even in the same table, because instead of having to like send an email or like Slack, like it sucks, right? Like working in person together on something is just it's just so much better. So whereas engineers like wait, also what time is it? Okay. So whereas engineers will need a lot of detail and really need to specify everything, like to an extent, right, for the user flow, designers are a lot more abstract thinking and they're a lot more creative. Creative in the sense that like, they want to like determine the user interface and they want to like really be more experimental. And that's usually like a trope, right? Designers are like more abstract, more creative, but you can argue about that if you want. In general, instead of like defining clear details like an engineer, you want to say, hey, here's the problem, and oh shit, this is not the right. Ignore the top part. Cool. So you really just want to like be more open. Say, hey, we're trying to create a confirmed dialogue on this page, but don't be like, oh, this is how it pops up. This is like what happens. You're really working together with them, and you want to be a lot more open-ended. Something that you can do is like when you're coming up with the feature ideas, go look at other apps or other websites that have done something that you really, really like. Take screenshots. Maybe like if you're feeling really risque or like really like, oh yeah, I'm gonna do this, like go on Figma, create some wireframes to help them out before they actually go into the user interface. And yeah, just give them like screenshots or like diagrams or anything that you can to help them understand like, hey, like this is really good, we should do something similar to that, right? Yes, so you want to be clear about the problem that you're trying to solve, but kind of give them their own freedom of like how to actually go about and solving that problem in terms of like the user interface. And like I said, you really want to talk about the abstract, but it's your job to balance the engineers who really think like, who need the details and who are like more realist. Like engineers will understand the limitations to certain technologies and the limitations to creating certain interfaces. Whereas designers will be a lot more creative, like the sky's the limit, because in design you can literally do anything that you want. And you can design any user interface, even if that user interface isn't plausible to actually engineer create. So you're gonna kind of be at the middle, balancing those two tropes, right? Balancing those two types of people. Then lastly, managing your stakeholders, the big bosses and everything. It's really just important to always keep them in the loop. Have them understand the product decisions before you actually go out and create it. Because if the person you're creating the product for doesn't like it and you've gone through all this work to actually create like something, then you're just gonna have to go over and restart. Always keep them in the loop and always make sure that they're satisfied. Really get their buy-in by building that trust, confirming with them that you're really eager to learn and that you really care about this project. And yeah, also a really big tip, don't schedule big meetings with everyone at once. Like as the PM, you should be having individual meetings, because something that'll usually happen when you have like everyone in the same room at the same time and all these like different conflicting stakeholders is then like people will be like, oh, like let's vote on how to design this, or like let's vote on how to implement this, or let's vote on this timeline. That's your job. So make sure to like really keep it separate and communicate to them in the different ways that they need. And yeah, that's it. Now it's time for tech time. So for those of you who haven't been here before, I kind of split up the product lectures between qualitative and then more like quantitative, hard technical skills. And last week I went over the internet, how the internet works, how it's really just computers connected together through wires. And yeah, now I'm going to go a little bit more into like the internet communication. I'm going to stand up because it's a lot easier to do that. So what this is showing right here, as you guys remember, all of our data is connected through wires of computer to computer. Even if it's wireless, literally all of our data is traveling through phone lines. And the way that it travels through, I talked about last week, but right here is an example of the communication protocols that actually take place when your computer is trying to communicate or trying to reach a different place. So right there is the user's web browser. It's like number one, it's where like the big web sign is. And what it'll do is it knows a website that it wants to go to. So for example, in this case, you're typing into your browser sub.example.com. Before it can actually go and find that server where all the files are hosted on, it has to find the IP address. And what it does is it'll go to a DNS resolver. So DNS just stands for domain name something, domain name something. If the S doesn't stand for something, but it is something. Yeah, I honestly forgot, but it basically resolves domain names. So the domain name here would be sub.example.com, and it finds the IP address, and then it connects it back to the user's web browser. So it'll go to the DNS resolver, and in this example, sub.example.com is actually pointed to a completely different domain name. So there are like records for every single website that are hosted that give a lot of different information. So one is an NS. So NS is a name server. It will associate your domain with an IP address. And then there is something called a canonical name. So a canonical name is when you're pointing one domain to another domain. So for example, I'm pretty sure if you typed in google.org, it would probably redirect to google.com. And they're using a CNAME. So a CNAME or canonical name will then kind of route it to the different domain. So in this example, sub.example.com is actually pointed with its canonical name to another domain.com. And then another domain.com has to say like, oh, like it's at this IP address. Then it sends the IP address back to the user's computer. And then now the user's computer can actually go find that content at that IP address. Sorry, that was a little bit complicated.
So does the user's web browser send the IP address, or is that from somewhere else?
Say that again?
So does the user's web browser like send their own IP address and their MAC address, I assume, right?
Yeah, yeah. They always send their own IP address and their own MAC address so that the data can reach back to them once it's ready.
So is the
Derek?
DNS resolver like have the like IP address of like pretty much like every website in existence?
Yes. So every single domain name is going to have a different like host for that domain name, and they're going to have their own DNS resolvers. So for example, like certain domain names are hosted on like Cloudflare, some are hosted with AWS, some are hosted on like Namecheap and GoDaddy. And Namecheap and GoDaddy and AWS will all have their own DNS resolvers where they'll basically have a table that says, okay, for these domains, this is the IP address. Or for these domains, this is the domain address that we need to redirect them to. Does it make sense?
So then how does the computer know like which one of them to query? Should it query like AWS or GoDaddy?
Yeah, I think that the way that it works is that there are like different stations in between that say like, hey, this domain is associated with this hosting service, and then it'll go to that like server. Yeah.
How does it work if I'm buying a domain? Because whenever I bought my domain, I had the choice like GoDaddy or Namecheap or whatever. And then how does it end up on that host?
Yeah. So basically what happens is all of these different like domain buying sites have access to like the rights to like rent or like buy one of these domain names. And then once they do that, it takes a long time for like that data to like set out to the entire internet. Like Derek was saying, like how do they know where to actually go get that, you know, specific like where to like host the DNS basically. And like GoDaddy or AWS or any of these will then notify the registry, like the internet registry, of like where that like new DNS or like IP address is going to be stored. So you buy it, and then GoDaddy or whatever will then say, hey, like people, we own this domain now, or like we're the ones who are like hosting it or hosting the data, and then that's why you can't like immediately go visit your domain, because they have to like take time, and it takes time to like propagate to all these different like servers. Cool. Oh, shit. Awesome. So now we're gonna talk. So we've talked a lot about like communication, how it works, and the ones and zeros. But what do those ones and zeros actually communicate? And they're basically all put over HTTP, which is Hypertext Transfer Protocol. Essentially, HTTP is text. It's just text, and it's like wrapping on top of like the binary that is being sent through these wires, and it is used for like every single message that is sent through. It's going to contain like where it's going to, the host, and a lot of different stuff. So like clients are going to send HTTP requests, and they're going to also receive them with like the server that we talked about last class. And we will go a little bit more into that. HTTP requests, as we were talking about, are basically like what are used to communicate. And these are all of the different types that there are. So, there's GET, which is usually for reading data. The client will send a GET request to the server, and then the server will then respond with data. And every single time that you actually reach the endpoint or the end website, they're sending back their entire HTML document through a GET request. Like you're saying get facebook.com. If you ever go into like your web browser, right click and click inspect, you can then go into like tracing the network requests. And if you do, you like get some really cool stuff. So I do this, and I do that, and then I go to network, and I click refresh. Let's go ahead and look at this. As you can see, it is a GET request. Why is it a GET request? Because I'm getting data, right? And the response is, let's see. This is the response. This is all of, this is the JavaScript, and let's see. This is the document. So all this, they actually like minify the code, so it's like really hard to read and really hard to like mess with, basically, to understand. But yeah, this is all the data that's being transferred by Google servers, and as you can see, we used a GET request to get that. Pretty cool stuff, right? And the same thing would happen if I let's see what happens if I type something in. Nope, that's not it. No. Oh, here it is. It's a post request with what I typed in. Let's see. What did I say? Okay, let's just send it again. Well, you can use GET requests to also like request data, which is what we're doing. And you can like pass in parameters, so you're not always gonna like get a like, you're not always gonna use a post request when you're like inputting data, but yeah, we'll get more into that. Basically, you get the idea. There are a lot of different HTTP requests. Mainly the only ones that are used are GET and POST, because when you're editing a database, you don't really need to say delete. And people do use put and patch. There are like a lot of different like pros and cons that we can talk about later, but just understand this is how all of that information that we were talking about that gets transferred is encoded. They're all in HTTP text. And it's really interesting. Like if you go on any website, like Facebook, for example, you can track all the data that's coming in and going out. And sometimes it's really scary. Like, people will do in-depth analysis of all the different calls and requests that are going on, and 90% of the shit that like is actually being requested or like given is just stuff about your data. Like, it's stuff to track you. It's not the actual information that you're getting for the search, or it's not the actual information that you're getting about what your friends are doing. A lot of it is tracking you, which is pretty crazy. You can check that out. Yeah. So let's see what happens. Let's try to clear this. Oh, that did not work. I guess I have to use the console in Safari a lot, but let's see what happens if I like this. It should be all the way down here. Let's try that again. So as you can see, it made a request to GraphQL, which is the database that Facebook uses to store all this stuff, and it sent information. Let's see, what did it send? Input, client mutation, feedback reaction. And what type of feedback reaction was it? It was feedback reaction number 4, which is that one. Cool? Magical, right? Isn't it magical? And I know you're asking, what is all this other shit? It's tracking your data. Right? Like, all they needed to do is that one post request. But no, they decided to do everything else too. And yeah, I was gonna like explain and like say, oh, here's like the entire data document that gets sent back and forth, but I just showed it to you guys in the browser. And now, you guys can ask me anything you want, or you can leave. But here are kind of like a list of general technologies that are going to be like really, really important to understand. And we're going to go more in depth for every single one of these, so you guys can have some sort of like baseline understanding and communicate with developers and also designers. But do you guys have any questions over any of these? We can talk about it. I can like give like a general overview of all of them if you'd like. Do you guys want me to give a general overview over everything, and then we can like dive more deep into those, or?
Anything like we specifically want to know, like that we really don't know about? Like,
Yeah. So yes, okay. You do those through APIs. APIs are application programming interfaces, which is a really, really broad term. But essentially, it allows 2 distinct applications to communicate with each other. And I think a really, really good way to understand that is, for example, the like weather.com, I don't know if that's a thing, but I'm sure it is. Weather.com has an API that different applications, different weather apps like on your phone or on your Android can use to access their data or to update their data. So for example, like Apple doesn't have its own website data or doesn't have its own weather data, right? Like on your phone, all that weather data is probably coming from weather.com. Weather.com has a public API, an application programming interface that it can call and retrieve that data from. So Apple's sending a GET request with the location to weather.com to get that information and retrieve it. Yeah. Oh, and then right here, for example, as you can see, it's facebook.com/API/GraphQL. It is interfacing with Facebook's API to then make changes to the database, right? Yeah. Oh, do you guys know what JSON is? Okay. Cool. Well, JSON is JavaScript serializable object notation? Something like that. JSON stands for... Wow. Guys, I am killing it today. Am I? No. So JSON's really, really simple. Have you guys all taken programming classes? Yeah. Do you guys know what a dictionary is? Yeah. Okay. It's just a dictionary. It's literally all it is. JSON is used to transfer data and to read data. It is the most widely used data format to communicate over the internet because of how simple it is, because of how extensible it is. With JSON, as a dictionary, you can have dictionaries inside dictionaries inside dictionaries inside dictionaries, and you can also model objects, right? So every single piece of information has a key, and then every single key has a value, and that's how data is transferred back and forth. So yes, most stuff is returned in JSON. Pretty much everything that you guys are building is going to be returned in JSON, at least at the API place.
So the API like basically translates or communicates between two entities, and then like if we want to like get some information from that, we give it back in the form of a JSON.
Yes. Yeah. And
like,
yeah, go ahead.
so it's like when you get a website, right? It's a string of files, not JSON. So like when the file when the website wants like information like data, not file data, it does JSON. It uses JSON.
Yeah, so actually, like, not all GET requests are going to give back JSON. Usually that's just when you're trying to get data, like, for example, this is probably stored in a JSON format, right? Celicia, her profile link, and then, like, the text. But you have to also return the HTML to, like, render the entire site, and that's not going to be stored in JSON. You're just going to return HTML to you. Yeah? Questions? Vince. Yeah, cookies are text files that are stored on your computer by websites. So what'll happen is a website has a piece of JavaScript code usually that says, hey, I want to store this information on Vin's computer, and then they can store a piece of text on your computer. But pieces of text can like store a lot of stuff, right? They can store a lot of text on your computer, enough to even like, sometimes you can even store images just with text on someone's computer. Yeah. But they're used to like track you or to remember your information. To remember your information for next time. Maybe you've logged into Facebook. Actually, we can actually look at the cookies that Facebook stores. Let's go into storage and cookies. Wow, look at all this information that is being stored about me. So this is my user, and let's see if we can open up the value. I guess we cannot. But this is all the data that's being stored on you right now. So this is probably your user ID, and then I don't know what this stuff is. It's probably encrypted. Oh, yeah, it's probably encrypted. But
How can you tell it's encrypted?
well, because F15828565857 doesn't really mean anything. Or maybe it's not encrypted, but it is at least obfuscated in some way, right? For safety reasons, right? No one gets your data except them. But yeah, this is all really interesting stuff. And you can definitely look at your cookies. I just don't know how. Like, usually it's a lot easier if you use Chrome. Safari really isn't the best bet. But there are like a lot of really interesting things you can do. But yeah, cookies store data about you on your computer. And usually when you contact the server, you send the cookie to the server, and then it sends you back like a response that then will then edit the cookie. Any more questions?
Question on like full stack frameworks. You know, like there's a lot of for like web development in general. Like maybe just like demystifying that a little bit, so we can like really get there.
Yeah. So what Jeffrey was asking about are full stack frameworks, and you guys all know what full stack development means? Okay. Well, full stack development, just to refresh, even though you guys already know, is creating every single thing you need in every single piece of technology to create an entire application. It's the front end, what you interact with, the back end code, and then lastly, it is, yeah, like the database. It's like being able to do all of that. Full stack frameworks make that easier. I know Marshall's really into Svelte.js, but there are a lot of them. I'm sure you guys have heard of Angular or React, you know, more. But yeah, basically they are usually abstractions or libraries on top of different coding languages, mainly JavaScript, that allow you to build all of those pieces really easily. I guess like the notion of a full stack framework is kind of deceiving because usually there are frameworks for every single part of what you're building. So have you guys heard of Flask? Flask. So Flask is a framework that is built on top of Python that can be used to create a front end and a back end. The full stack. And then there's also React, front end, back end. There's also Swift. Swift can now be used to create a back end. There are a lot of different frameworks, and they're all used and built on top of programming languages, so then you can create something. But yeah, at the end of the day, like most web front ends are like then transferred to HTML, CSS, JavaScript, and then most backends are just running that native code. Derek? Yeah, sure. Node.js doesn't really relate to a browser's engine. Maybe someone fact check me on that, but what a browser does is it receives that HTML code that you get from a server, and then it renders that onto your screen. Right? Like, there isn't like some sort of image that Google is giving back to you to say, hey, like, here it is, like, create the search box or whatever. No, Google has HTML tags and shit and CSS that it's returning to you, and then your browser then renders that and uses its instructions from Google to put that onto your screen.
I don't know what that means.
Say that again?
The reason why Node.js was created was like when you use the Vue engine from Chrome, like this section was the back end of JavaScript. I don't know exactly.
Yeah, Node.js is usually used for like backends or to write server-side code. It's not used on the front end, which encompasses like HTML, CSS, and JavaScript. Yeah. Maybe like one or two more questions. I know it's like pretty late, so I don't want to keep you guys for too long. But more questions? Aditi?
Why is like cloud computation so much faster? Because they're just like transferring it to like another computer
Yeah.
to do it for them. So is it just because it's like more performance and that it's working?
Yeah, so I mean, it's because you're asking computers that have like a lot more computational power than you and that are literally designed to do some of these tasks. So, for example, there are a lot of different types of computers because there's just like a lot of different things you can do, right? They have computers that are specifically built for gaming. And your computer, your trusty old Lenovo, is not going to be great at that. So it's literally better for you to like send a request to another computer to do the computation for you and just return the data than for you to do it. Or like they're computer specific to like Bitcoin mining or like specific to, you know, like rendering videos and stuff like that. Yeah, that's why cloud computation is good because then your own computer doesn't have to. Someone else can do it. Yeah, if you guys want to leave, you can. And if you guys want to stay and ask more questions, we can do that too. It's all good. All good?
Good luck.
Cool. Sounds good.
Oh, wait,
Also, anonymous feedback. Seriously, it's anonymous. So you can roast me, but please like tell me what I can improve upon. I know this lesson I didn't do like an interactive kind of part, which sucked, but I will try to work on that. I just had like a lot of stuff I wanted to go through. Cool. Yeah, of course. If you guys want to talk, come through. I'm turning off the mic.